Hello, my name is Holly. I'm a DPhil student at the University of Oxford, and I'm going to tell you a bit about myself and my project. So I'm from Cornwall and I studied at Bodmin College, and for A-levels I did maths, chemistry, physics and geography. And I chose these subjects just because I enjoyed them and I was quite good at them. So I decided to go to university and I studied chemistry at the University of Bristol, and this was a 4-year integrated master's course. So I studied chemistry because I enjoyed it at A-level and I felt like the scope of its application was quite broad and covered my interests. So we had lectures throughout all 4 years, and in our final year we also conducted a research project. So I'm now doing a DPhil at the University of Oxford, and I decided to do this because I enjoyed doing my project in my master's course and I wanted to continue to do research at a university. So I'm on the inorganic chemistry CDT, so we have a 6-month talk component before we start in the lab. So this consisted of lectures, assignments and industry visits. And this has been really beneficial, and I felt like I've really improved my kind of writing, presenting and critical reading skills. And I've also really enjoyed being in a cohort. So my project is about using polymers to make better batteries. So here we have a diagram of a lithium-ion battery. So you have the electrodes, the anode and the cathode, and these store the lithium ions. And during discharge, the lithium ions move from the anode through the electrolyte and into the cathode material. And the electrons move via an external circuit, and then this provides the energy. Okay, so why do we need better batteries, and what do better batteries look like? So we want batteries to charge much more quickly, and this is really important for electric vehicles, because for people to want to use electric vehicles, you want the charging experience to be as close to refuelling a regular car as possible. And at the moment it takes much longer. This is mainly limited by the electrolyte, as fast charging causes a degradation. So we'd like a new electrolyte material. We also want batteries to be safer. So at the moment we have liquid electrolytes, which are highly conducting, but they're also flammable. And although fires and explosions are rare, if you're going to use these batteries in vehicles, the safety standards are much higher. We also want the batteries to have a longer lifetime. So liquids in the electrolyte tend to degrade faster than solids, and also the electrodes undergo quite a big volume change when the lithium kind of enters and leaves, and this causes cracks and gaps to form in the material, and the battery degrades this way. Okay, so how can we use polymers to make batteries, to improve batteries? So polymers can be used as a solid electrolyte material in the battery. So some polymers, mostly those with oxygen atoms in their backbone, are able to conduct lithium ions. And these in general are not flammable and they're more stable. We can also use elastic and adhesive polymers as a binding material in the electrodes. So the active electrode materials are particles which can be dispersed in this binder. And this helps to reduce the formation of cracks, and the binder can deal with the volume change, thus increase the battery lifetime. So the aim of my DPhil is to develop new polymers for use in batteries. They'll consist of distinct blocks which will provide the polymer with the right properties that we want. So a middle block can be ionically conducting, and then the outer blocks can provide the right mechanical properties. So we want it to be mechanically strong, yet adhesive and elastic. And then these properties, the polymers can be tested. So their ionic conductivity, their adhesion strength and their mechanical strength can all be measured. So I'm yet to start, but hopefully we'll develop new polymers which can meet the needs of future batteries. Cool. So thank you very much for listening, and if you want to find out more, have a look at the website.